there. Thanks everybody for joining us today. One more day on the GIRA LATAM. And today we have two more sessions to go. I have here with me, standby, ready to take action, Audrey Meng. And she's going to deliver for us the session called GitHub Actions versus Azure DevOps Pipelines. I'm kind of looking forward for your sessions. Hopefully I will learn some new tricks today and understand the difference between both. But before get started, I just want to say a big thanks for our sponsor, Phaeton Technologies. Let me just run a quick video to show the amazing products and the security products they have on the market, and then we can take from there. Yeah, great. For more information, please visit Phaeton Technologies website. Okay, Audrey, do you want to do a quick kind of intro about yourself, and then I will share your screen and you can take over from there?
Yeah, sure. Hi, everybody. Can you hear me?
Yeah, all good. Yeah, all good.
Okay, good. So, hi, everyone. My name is Audrey Mungo. I am a software engineer. I am based in Accra, Ghana. And yeah, that's about me. I'm a passionate about technology and public speaker, and I'm totally happy to be here.
That's great. Yeah, thanks very much for helping us to spread the word and do this community work. Is always nice to share knowledge with other people. That's great. Yeah, thanks very much for that. Yeah, everybody. As I already agree with Audrey, let's say if you have any questions, please feel free to type on the chat box, and then to make our session a bit more interactive, I will, when the questions come, I will basically just ask those questions to Audrey, and we can take from there. Okay, I believe everything's ready. Let me just share your screen. And yeah, all good, Audrey. Yeah, please take over. And I will be here on the background. If you need anything, let me know. And if there is any question, I will, just ask for you, and we can take from there.
All right.
Thank you.
Thank you. So, hi everyone once again, and this is Audrey. As you can see from the slides, I'm a software engineer. I'm based in Accra, Ghana, and if you want to reach out to me, you can reach out to me on LinkedIn with this name, and on Twitter with my Twitter handle Lamings. Yeah. So today's topic is about Azure pipelines versus GitHub Actions. So today we want to expose ourselves to these two technologies. There are a lot of debates around saying, why is it that the two exist? Some people prefer to drop one, and others still don't understand why they are maintained. Why is it that we even have both? And if you had experience with any of them or both of them, you understand that they do pretty much the same thing. But there are still reasons why they are not the same. There are still reasons why they are different products, and they are still there the way they are. So next slide, we have the Azure DevOps. So Azure DevOps is just like the umbrella. It has a lot of other services under it, and it's a Microsoft product. And under this big service, which is the Azure DevOps, you have other microservices, which are, I wouldn't say microservices, but other cool services under it. Azure Pipelines, Azure Boards, Azure Test Plans, Artifacts, Azure Repos. And today, the focus for us is Azure Pipelines, because we want to run pipelines. And yeah, so just for you to know that there are other things to focus on when it comes, there are other services that Azure DevOps has to, can provide. It's not only Azure Pipelines, but for this presentation, we just stick to Azure Pipelines. So why do we, and just a little, I just want to draw your attention here. I have two screens. Sorry about that. So I have my slides here, and then I have the camera here. I'm not distracted. If you have any questions, you can just ask them. But sometimes I just have to look this way to make sure that everything is on point. Right, thanks. So why do we have Azure pipelines, for instance? It's just for us to be able to build, test, and deploy our CI/CD with any language and platform to the cloud. So we have our code base somewhere, and we make changes to it, and we want these changes to reflect instantly. They go through a process that we've already defined, and then after this process, all our changes can reflect. And the inspiration behind this talk is more of you as a software engineer who is not a DevOps engineer, just to let you know that it's actually possible. And at work, I am not a DevOps engineer, but I was tasked to deploy my websites to the cloud. And I became curious, like, how is this done? And I learned a lot during that process. And from time to time, I'm actually using Azure to deploy my mini project or my side projects on. And it's kind of cool. And I didn't receive or go through any formal, how will I say, any formal path to become a DevOps engineer. I'm still a software engineer. And this still works for me because I know these basics. So I can actually use these basics to do my work. So yeah, we want to have pipelines, and we want to define a flow so that we have, how do you call it? We can make changes, and the changes go through the process that we've defined, and they reflect to the application that we are actually modifying. And the next slide is we have steps. This is based on my own experience. Somebody can tell you otherwise, but these are the few steps that I took in order for me to be able to actually deploy my website and monitor the changes and have them reflecting. So the first step is to open the Azure DevOps organization and create one, then create a project, then create a pipeline, then choose the source code, select a repo, validate permission, configure your pipeline, edit configuration, and run your pipeline. So if I was asked to go through that process again, these are the steps that I would take, and they would not change unless maybe for one reason or two, maybe, depending on the complexity of your project, you may go beyond these steps. But to me, these are the basics that you need to know. Once you have this figured out, you can actually do your deployment without really much of a hassle. So the first step is to create an organization on Azure DevOps, and you do that on the portal, right? You go to your portal.azure.com, and then you create an organization. You can just type in the search bar Azure DevOps, and you will be asked to create an organization. Then I already have organizations created, so I'm just taking you through this process. Then the next step is to create a project. So this is the screen you will land on. You will land on when you create a project. And I already have a project, but you can create a new project here. Yeah, you can create as many projects as you like. And since I've been using it, I just want to mention that I never paid for a dime, like totally free of charges, right? So now the next thing is then you create a pipeline. When you are in there, you can, in the Azure pipeline, you go to pipeline, then you can create one pipeline. I have created them already, and the fact that it's green here means that it went through the process that I defined, and it actually worked. And I just want to point it out. It doesn't always work, and that is okay. You just have to keep on trying until it works. But yeah, I have these predefined pipelines here, but I can also create a new just by clicking this button. Now, the next step is You choose a source code. Where do you host your code? On which platform? So you have you have a choice, as in where your code base is hosted. You have buckets, you even Azure repos, you have other Gits, you have enterprise servers, so you have a lot of you have a choice here, and you can choose where your code base is and pick it from there and start running your processes. So for us, we have our code hosted on GitHub. So I've selected it. So once you choose GitHub, you will land on such a page. You have GitHub repositories already. How will I say it? GitHub repositories already lined up, and you have to choose from them. Once you choose the repo, you'll be prompted to give Azure Pipelines access to that particular repository that you chose. So after that, after choosing the repositories, you will land on such a page. You actually, this is just an Azure Pipeline page, just explaining to you what the service does and giving you more information about how to use the service. And after that, because you're a software engineer, usually, I don't know if many of us find time to read this, but yeah, you just know what the thing is supposed to do, then you go for it. So after that, you will have to select it. From here, you can actually change the repository you want to, but automatically to detect the repository that you selected in the first place. So then you approve and install Azure Pipeline. And after that, then you have to configure your pipeline, right? So you have set of, how do I say, packages that you can choose from. If it is a Node project, if it is a React project, you have predefined pipelines that are already there, then you can choose from. And for me, I'll take Node because it's a JavaScript application that I am actually deploying. And after that, when you choose this, you'll be prompted with a basic YAML file that has a set of steps to deploy a very simple pipeline, right? And of course, when you land here, you can actually, this is the part where you have to customize. And one issue I ran into with this YAML file was actually the version of the Node. So with Azure Pipeline, you have a version that is quite old, which is the 10. I think the version of Node right now, I think it's 15 or 14-ish. I don't have it in mind, but yeah, you can always check it. And yeah, try to, whenever you have to make sure that this YAML file that you define has the exact Node version of your application. Very, very important. It's very important. Otherwise, your pipeline will run and it will fail. Right. So the next thing after you define this, you have to edit the configuration. So for you to edit the configuration, you actually have to add scripts in order for you to enter your credentials that are related to your GitHub. Make sure that you add this. Like you have, as you can see, I don't know if you can see clearly, you have this part that has been modified on the previous slide. You have this script, you just have the npm install, the run build. But now, when you go next, you have the Git configurations that you have to add, because you have to add these configurations to your YAML file so that you can you can actually connect to your GitHub account and you are getting authenticated, and yeah, and then you can run into your process. After you edit the configuration, you have to run the pipeline. And I just want to point your attention into this variable that is here. This variable is actually defined here. So when you define your, how will I say this, your pipeline, you can save variables in there, and the variables that we are looking for in this context is your keys from GitHub. But we will, how do you call it? We'll go to that stage, yeah. And then you add them there. These keys will just make sure that we authenticate you, and yeah, we know you are who you claim to be. Good. So now next, after editing, you run your pipeline, and you will land on such a page. And on this page, you will see that jobs have started. So we have one job, which is actually running, going through the whole process that you've defined in your YAML file in order for the application to be successfully deployed. I hope you are following, and okay, there are no questions so far, but please stop me if you have any questions. All right. So now you have the status is queued because things are running behind the scenes, and now you can actually have the full, when the job is starting, it will open up. You click on the job itself, and you can see all the stages of your job. And this is how it will look like when things have failed, when things are falling apart. And it's going to happen quite a lot of times. It's not to discourage you. You can be lucky enough to run your pipeline and everything goes fast and cool right from the start, or not. And you have to figure things out all by yourself. But thank God, we have logs that are provided, and this can be a summary here of what is actually happened. And we can actually click here and view the complete log on another page. And this will give us more information about the pipeline that we run, the problem that we run into. And once we know what we run into, the problem that we run into, we can easily fix it. And this is how it will look like. This is a lot to read. This is a lot. But I mean, I'm talking to IT professionals, and we all know how our field is. I mean, you just have to be really, really, really patient. Yeah. And yeah, I think that is it for Azure Pipelines. That was an overview on how you can actually set up your pipeline and deploy your application, and then get access to GitHub, have a basic YAML file, modifying it to suit your needs, and tracking the progress of your application whenever you make changes, push the code to GitHub, and the job gets triggered on Azure Pipeline, goes through the process, and boom, your change gets reflected. So at this point, any questions? No, because I'm about to tackle the next part of our talk. All right. So now the next part is GitHub. So just like DevOps, GitHub also has services under it, right? And one of them, GitHub Pages for hosting, and more than that, GitHub Copilot. I've actually not tried it just yet. Hopefully, I'll get the opportunity to lay my hands on it. Well, let's see how it goes. Yeah, I've seen people using it, and it was quite interesting, but I've not gotten the opportunity to use it myself just yet. So yeah, the next is GitHub Actions, and this is what we will focus on for this presentation. Right. So GitHub Actions is also a CI/CD tool for the GitHub flow. So, and that is where people are actually confused, right? They do the same thing. Yes, they do. It's the truth. But I could say that the difference is, how do they do the same thing? So even though they do the same thing, how do they do it? And yeah, this is what this presentation is all about. But I just want you to know that you are not wrong to think that they actually do the same thing. All we want to do is to have a pipeline that we can run, track our changes, and boom, we are out of here. And you can achieve that with both. All right, so next stage. Here too, we have steps. I came up with set of tests and yeah, steps. And these steps still don't change for me. They've always been the same. And hopefully they won't, okay, well, depending on how, what kind of application you are trying to deploy, depending on the complexity and depending on the audience that you are targeting, depending on the level of complexity, yeah, these things might change. But for now, this is working just fine. So let's go through the steps. So the first one is you log into GitHub, of course. You click on Actions, and then you go to the home page, and then you add the home page to your package.json file. Then you add the repo, the link to your repo, the landing page in your package.json. Then you install npm save git pages. Then you generate token. Then you create secrets. And then you update the YAML file with the deployment steps. And then you set GitHub pages root to be on GH pages. You confirm successful deployment. This is what we are going to. This is basically what you also have. And I tried my best to make it 8 points because, yeah, I'm not actually including the failed ones. But yeah, these are the steps that you can actually use in order for you to do a pretty cool, okay deployment. So you log into GitHub. This is the page you are logged in. I am logged in. Yeah. And then you have here, I am not sure if you can see well. Hopefully you can. But you know you have this set of actions that you can take. All these call of for action buttons that are here, you can just select action. When you click on it, you will land on such a page, which is on this page, I kind of call it a marketplace where you have a lot of suggestions for pipelines that you can use that are appropriate for your project. So GitHub has already detected the kind of pipelines that would be suitable for you. So you choose one. So in this case, the Node.js one will be suitable for JavaScript projects. You can even have suggestions about based on the programming language that you are using. So for JavaScript projects, you have this. I believe this is Rust. I can't see. Well, this is Rust. You have set of programming languages. So when it detects, you can suggest it to you. Like these are the kind of flows you would want to integrate so that for a successful deployment. So yeah, then after that, you will have this YAML file, which will, when you select the flow, and you will have this directory created into your project. So you will have GitHub, the name of your repo, then that /GitHub /workflow /node.js.yaml. And yeah, this is also the basic pipeline that you will have. So if, for instance, if you are deploying something that is so basic that it doesn't have tests in it, I will highly advise you or recommend you to delete this step. Just take it out, just for testing purposes. So if you want to deploy an Hello World application, just for you to see or to test if this flow is more appropriate for you, you can do that, but you need to remove the test file. And also, you realize that the GitHub Actions has versions of Node that are already quite advanced compared to the ones that we had with Azure pipelines. Over there, we didn't have we didn't have this version. We only had one, which was 10. But here we have quite some cool, we have lots of versions. So depending on which version you are running, which version of Node you are running, you have more choice here. So now that you have it, yeah, you have to commit those changes. You commit them. Then you go. So on GitHub, you will have to enable the GitHub pages, right? And when you actually enable it, you will have a link that is generated. And when you take that link, that will be where, that is the landing page. That is where we will land whenever we make the changes. And that is your repo out there, basically. So whenever you make the changes, your code, your application is hosted on this URL. So whenever you make changes, it will reflect on this URL. So you have to add this script, this line, depending on your, how do you call it, on the URL that will be generated for your repo. This is for my own, obviously. So you have to add this script. And once you do that, you run a command like npm GitHub pages. This is to enable GitHub pages to be, how will I say this? This is to enable GitHub pages into your repo. And whenever you push the changes, okay, this is to enable GitHub pages to be picked whenever you make the changes. You need, instead of you to pick the directory, the root directory, this command will generate another directory into your project. So there will be a branch that will be created, and that branch is GitHub pages branch. And for your CI/CD, for how will I put it in a more comprehensive way? So for all this process to run, we need to enable it. It is super, super, super important. And we need to change the branch from main to GitHub pages. And we'll see that later on. So when you run this command, a branch will be created in your repository, and that branch will be the one you will have to connect to whenever you run this for your build and everything to run properly. You need this, trust me. Now, you have to generate tokens because, well, we'll have to modify our YAML file in order for us to be authenticated properly, giving the right access to the right person. Yeah, so you generate tokens and you have to update your YAML with that. So you see now, this is what you are going to add into your YAML file. You have to add this env file, this env step, and in there you will define your GitHub tokens, and there is a convention actually. So actions deploy access token is actually the name for the secret. So whenever you create your secret, try as much as you can to define a variable like this because it's convention. Yeah. And this is based on research. So use this so that nobody gets confused. And then from there, we have to set the root to GitHub pages. So when you go to GitHub pages, you will have two branches. You have the main or the root directory, and you will have the GitHub pages directory. And you have to log in to the GitHub pages directory. And yep. Then after that, you have to confirm your deployment and make sure that all the workflow goes through all this. So you see all the actions are here. Build deployment, remove section 2, anything, any commit that I made, everything will be recorded here. And you will have, when you go to the all workflows, you will see them listed here. and make sure they are green, because the moment we see a red anywhere, this doesn't sound good for you. Yeah. So make sure they are make sure it's green so that it passes. Yeah, so that is it for GitHub Actions. It was actually quite short, but yeah, that is just the experience that this is just my own experience. Maybe some people will find it longer than GitHub. Some people will find it longer. It takes a longer time for them to actually define all these flows, go through the processes, go through the steps, and but yeah, it's, to me, it is shorter. It takes less time to work with GitHub Actions than to work with Azure Pipeline. Just my view. Right. So are there any questions? This one was quite quick. All right, so we continue. And now let's go to rating both. So from my experience and research that I did, these are the things that I want to discuss when it comes to comparing both technologies and which one should you go for. So in rating both, I observed the learning curves, the source code, the deployment groups, the variable groups, which to me are really key points to take when you consider working with one technology or another. So here are the learning curves, for instance. Here, with Azure Pipeline, you need a minimum knowledge of about Azure. So just minimal, like opening, creating an organization, understanding, not deeply, but understanding that they are more involved. You can do really more. It takes a longer process to set up because, as you could see, we went through creating an organization. After creating an organization, we had to go through the process of, there's just a lot to click. You are just exposed to way too much at a time. This is my own observation, but yeah, you are actually exposed to a lot at a time. So it takes longer for you to figure out things over there because it's quite vast. You can easily get lost into the process. Yeah. But with GitHub Actions, it's actually pretty simple. So your code base is already hosted on GitHub. So basically, you don't have to look for other places where to get your code from. It's on GitHub. So it's just a click away. Action, boom. And then after we click on action, that's it. We are there. We are prompted to choose a workflow from variety of ones, and we are suggested the ones that are close to the work that we are doing. And we just pick one, and we modify it to our own, to suit our own needs or to our own tastes. And you actually don't need to choose. Your code base is already there, so you just pick it. This is the first point that I took from it. Pipelines, Azure Pipeline takes quite some steps in order to achieve this. And you need to create an account, Azure account. Yeah, and GitHub Actions. Yeah, your code base is already there on GitHub. You don't need to create a particular account for nothing. So it's pretty simple to learn compared, GitHub Actions, it's pretty simple to learn compared to Azure Pipeline. Now, the source code. Even though it's easier with GitHub Actions, wouldn't it be still nice to actually have options? Like, why do I have to be restricted to GitHub only in terms of source code? I'm not saying that it's impossible, but this is what I've been exposed to. tech can change. Maybe later on, Microsoft would decide that, hey, well, we can actually modify this and being able to create, being able to allow developers to also pick from other source code, like other um, um, other clouds, other technologies that can that host code bases. Why not? Bitbucket, any other one. But for now, no. So even though it makes things easy, your code is already there. You don't really know. You don't really need to know so much. It's still kind of restricted, which is we want to have a lot of flexibility. But this is one side, one thing that I noticed with GitHub Actions. But Azure Pipeline has, you can actually choose from multiple platforms. You can choose from GitHub, you can choose from Bitbucket, just as we saw on the slide, the previous slide. You can choose from many of them. So yeah, this part is quite good. Now, deployment groups. So the good part is that on Azure, when you create organizations or when you have an Azure subscriptions, you can actually create you can actually have machines that are parts of that are logically related. So you can have many virtual machines that belong to a particular sector. Or let's just say a department has virtual machines and you want to deploy applications on many of them at the time. Azure pipelines can allow you to do that. And GitHub Actions cannot. Because, well, you have one source code, right? And I'm not saying that it's not, like, I'm sure maybe they're exploring how to do that on GitHub with GitHub Actions. I don't know, but for now, you can't do that. You can just deploy it somewhere. But a group with Azure pipelines, you can actually target a particular department into your organization, your Azure organization, and deploy your application over there. So if you have an organization that has that is already that has an Azure subscription, I'll say GitHub, I'll say Azure pipeline. You should definitely go for it, because why not using all that you have in your power? You already have an organization that already has a subscription. And if there is a need to upgrade the subscription, no problem. But all these services are already there. So it will be suitable when you are in an organization. But if you're an individual and you are working on projects that are your own projects, you can go for the GitHub Actions. I think that is a good alternative for you. Yeah, I think so. Now, variable groups. Yeah. So GitHub Azure pipelines, you can actually store these keys somewhere and use them for different pipelines. So you define a lot of pipelines. As you could see, we could, for literally one project, we could define a lot of pipelines. We can run this and define another one, create, create different pipelines, right? So it's actually very flexible in that sense, because again, if you're an organization and you like to keep it and you have this power within your hands, why not use it? So this is the power that Azure pipelines will give you, but GitHub Actions won't. Because as we could see, you select a single project, right? You have a repo. You select a single repo and you define all this for this particular repo. That is it. that pipeline belongs to this repository. That is it. And it's not the case with, but with Azure pipelines, you can actually have many pipelines, right? Define them. So it's actually, I'm not trying to side by Azure pipelines. It may seem like I do, but I'm not actually siding. I'm just trying to tell you that there's actually this possibility there. And yeah, get to know this. So in a nutshell, if you're an individual and you're working on some cool projects, even within your team, and it's a single project, you deploy it to a particular pace and you make all your changes, you have one pipeline, you can go with for the GitHub Actions. But if you're a wider organization with a lot of things ongoing and many people to actually manage these pipelines, because you can have people who manage pipelines, you can go with the Azure pipeline. Yeah, and yeah, these are the observations that I wanted to share with you, and I hope you liked it. Yeah, so the resources that I use, official documentations, of course, for Azure, GitHub, Azure DevOps, and all that. But the main thing that really helped me understand these concepts and give me a lot of insights, as in how to use these things or how to try to choose between the two technologies, is actually this book, DevOps for ASP.NET Core Development. It's really a good read for this use case. So if you think that you need to learn more about that or try to dive deep into getting to know which one to use for your deployment, I would highly recommend you to read this book. Yeah, I would highly recommend you to read this, aside the official documentation for further research. So on this note, thank you. Thank you so much for having me here. If you have questions, you can go ahead and ask them. I'm happy. Thanks to the sponsors for this. I'm really happy to be here. Thank you for having me. GIRA Speakers 2022. I'm happy. Thank you.
Great. Yeah. Thanks very much for all the information. I think you explained too well, and we didn't get any question. I think everybody managed to understand, everything. I have a question myself, if you don't mind. I just don't want to put you on the spot. Usually, when I'm talking to clients, especially when talking to cloud and Azure, and then the first, I wouldn't say the first question, but one of the questions that come is always about cost. And then, based on everything you have been talking so far, is there any cost difference, or from GitHub, the actions you are planning, are they free, or they need that GitHub a special subscription? I'm not sure if you have any information to kind of talk around that.
So far, I have not come across any costs. Mm-hmm. I have not. So I've been using this on my personal projects, but I have not come across any costs.
No. Okay, that's a good news then for everybody. Okay.
Yeah, but don't get it too twisted. If you have an organization, as I said, if you are planning as an organization to use, for instance, Azure pipelines, just talk to your provider and talk about your subscription. So does it incur costs for whatever work that you want to do with the service? So yeah, always make that inquiry. But so far as I'm concerned, no, I've not paid for anything yet.
Okay. And another question for curiosity. Let's say if you have been using GitHub Actions and you never used before Azure DevOps, can you kind of transfer the knowledge you have already with GitHub, into the new learning and vice versa? Or for somebody starting from the scratch and one of the platforms is very different from each other?
Yes, even though they are very different. That's a good question, though. Mm-hmm. Thank you. So even though they are very different, there are a lot of similarities. As you could see, yeah, so we have the YAML file, which is we define actually all the steps that your project will go through in order to be deployed. So this file is the same, basically. There will be some few tweaks, yeah. So you have to keep the YAML file knowledge that you have will be the same for all of them. So just know that you need a YAML file. Just know you need a code base somewhere. Now, when it comes to code base, when you go to Azure pipelines, you have the choice. So you can choose, your code base can actually be your code can be hosted on GitLab, Bitbucket, other platforms, and you can choose it from there. But when it comes to GitHub Actions, you only choose from GitHub.
Okay.
So these are the basics that you need to know, but the YAML file should be there. Another basic that you need to know when it comes to knowledge transfer, something that they have in common, is the secrets. So you will need to create variables that are linked, that are linked to your GitHub account. And I'm assuming it's also the same for Bitbucket. I've never worked with it, but you need these secrets. So they come together. It's not all that different. It's just, let's just say the platforms are really different, but the work behind the scenes is quite similar. Yeah.
Okay. Okay, great. And then, thanks very much one more time, Audrey, for spending the last few minutes here with us. It's always nice to share your knowledge. And thanks again for our sponsor, Phaeton Technologies. And we will have a small break now. And the next session is coming in a few minutes, in about, let's say, about 10 minutes, 13 minutes, we are going to start our new session. Okay, thanks very much, everybody, again, for watching this session and enjoying the recording, when it's ready. Okay, thanks very much.
Thank you.
See you in a few minutes on the next session.
Hello, everyone. I hope you can hear me. I am Toshka. I'll be the next moderator for the session. And I think we're just waiting on Praveen to join. If Praveen, you would like to say hello. Oh. Awesome, there we go. Cool, so I guess we can get started. So welcome everyone to the second session of the GIRA LATAM speakers for the day. We have Praveen here, and he will be talking about serverless deep neural network with Azure Functions and machine learning.net. So that sounds really interesting. And just before I'll let him introduce himself, I'll start off by thanking the sponsor, Phaetian Technologies. They are a security company, and they've kindly sponsored the event. So that's really awesome. And I'll just go ahead and play their video. Cool. So they are sponsoring our event. So please don't forget to register on the form. I will post it in the chat again. And they are giving out FIDO keys for the lucky winners. So yeah, I guess I'll hand it over to Praveen. Hi, Praveen. How are you doing?
I'm doing great. Thanks for asking. How are you doing?
Good, thanks. If you would like to introduce yourself, I can let you take it from here.
Yeah, sure. Let me share my screen. Just give me a thumbs up if you can see that. Okay. Okay.
Yep,
Can
looks good.
see good. And the slide deck.
Awesome.
Okay.
Awesome. Take it away.
Okay. Thank you. Welcome everyone to today's session on serverless deep neural network with Azure Functions and ML.NET. So before I proceed and start the session, I would like to say thanks to the organizers, the sponsors, and the team that has been working tirelessly behind the scenes. I know it takes a lot of effort to conduct such kind of conference or a virtual conference. It's really challenging, and I really appreciate the effort that has been put up by the team behind the scenes. So with that, let me start the presentation. A brief introduction about myself. I'm a cloud architect at Harman. It's a Samsung company. The domain I work for is professional audio, video, and control. And area of expertise is cloud and distributed computing. And I'm very much interested in the latest of the technologies, which is in artificial intelligence and machine learning, and like working in the professional audio domain. That means we need to tackle a lot of devices and interaction between them. So I'm predominantly very much interested in IoT as well. I'm based out of Bangalore, India, and Azure certified and a member of .NET Foundation. So the agenda for today's talk is I'll be covering these topics. One is the serverless. What is serverless? What is the SEO function? What is deep neural network? Then the image classification, ML.NET, followed by a small demo. Okay, so serverless. So why do we need a serverless first of all? So what happens is if we the traditionally the companies used to invest a lot in their data centers. They used to maintain their thing, and they used to uh, uh, they used to have an overrun of the cost for those things, for maintaining those things. So sometimes they may be utilized properly, sometimes they may not be utilized. And for example, if there is a spike due to some event happening, then they used to procure those things well in advance, and it's just a waste of resources, as well as it's not very cost effective solution that time. But with the advent of serverless, those all things have been taken care by now the cloud providers, which could be your Azure's, Google, or AWS. These are the leaders in the cloud technology. So, but there are others as well in the industry that provide this kind of environment. And when we say serverless, it's mainly about executing your code and paying for that only, not for the resources that you need to buy, or the infrastructure that is required for that one. So that is built based on the uses that you are going to have. Also, it allows you to take care of like pick and choose kind of a thing. Like if you want to have a high end security, you can just leverage that one. Or if you want to have large big data, then you can have that as well. So all those things are very much pick and choose model, and whatever it's required at that point of time, you can just quickly get those things through the cloud providers. Coming to the Azure function, so Azure Functions is a serverless offering from Microsoft, and it allows you to execute your code. And the code means it can be a function. Okay, so that is why the name is function. So it allows you to execute your function, whatever you have written in your language, maybe .NET, C Sharp, F Sharp, or Python, or Java. So it has a lot of support with multiple languages. And there are some events on which the code gets executed. So for example, if you are uploading a file to a blob storage, then in that case that trigger will be there. Or if you are want to send an email based on some condition, then those kind of things can be easily triggered through this Azure function. So it just allows you to focus more on your business instead of focusing on the infrastructure part of it, of your business. Now, there are multiple triggers that are available within the, or the connectors that are available within the Azure function ecosystem. So most popular are the ones such as storage, wherein you have a queue, blob, or a table. If anything gets added to these items, then you will get a trigger out of that one, and you can execute Azure functions for that one. Uh, Another one is a Cosmos DB, wherein you want to make some predictions, or you want to do some analytics. If something gets added into your database, Cosmos document database, then you can easily write a trigger out of that one and execute those things. Then you have service bus, then Twilio. Twilio is used for SMS and email triggers. Now coming to the deep neural network. So before I jump into the deep neural network, I'd like to touch upon the artificial intelligence, machine learning, and where does this deep neural network reside within the whole ecosystem of artificial intelligence. So if you look at the top one, you have the artificial intelligence, where we try to mimic the human behavior that we have. So the way the humans interact, we try to mimic that behavior using artificial intelligence. And the next one is the machine learning. So machine learning is a subcomponent of artificial intelligence. The thing is here, the things are done manually. So for example, if you want to train something, you need to have a prior understanding of those things. You need to know what all features are present in that problem statement, and how the you need to identify those features first. So we need a experts for those things, to who have a broad domain knowledge, and with that domain knowledge they can identify the features within the ecosystem, within the problem statement that they are trying to solve. So there is an intervention of domain knowledge by a person that is required in terms of a machine learning. Now next comes the neural networks. So neural networks are the ones which allows you to identify those features within the problem statement on its own. So there is no manual intervention required. There is no domain as such required to solve a problem using a neural network. The only concern here is it takes more time compared to the machine learning, where the feature prediction is done manually, whereas here it is done automatically. So you need a good amount of compute to identify the features within a problem statement. And the deep neural learning is about having multiple layers so that you can solve complex problem. If you're going to have an artificial neural network, which is a plain vanilla kind of a neural network, you will be able to solve the problem, but those are very kind of a trivial kind of a problem that you can solve. But with deep neural network, you can add multiple layers so that each layer will try to extract the information from the problem statement, identify the features from the problem, and it may that gets carried to the next layer within the neural network. So if you increase the number of layers, that means you will be able to solve complex problems using a deep neural network. So as I said, there's a basic difference between machine learning and a deep learning. So if you look at this diagram, you have an input, set of inputs, and you have a feature extraction phase. So this is all done by the domain experts. So they identify the features within a problem, and once they identify those features, they will feed it into the uh, neural network and to learn. So once the learning is done, then after that we will get to know the outputs out of that one. So the only challenge here is feature extraction, which is very cumbersome activity, as well as which requires a deep domain knowledge for that to happen. Whereas in deep learning, you just pass in the list of inputs, and the number of the layers within the deep neural network will try to extract the features based on the past experience, based on the data that it has seen, and it will try to come up with some features on its own, which can be fed for learning purpose. And once the learning is done, then we'll get the output. So as you can see here we can have we can see three layers of neural layers that are present here. So it can be either three, it can be multiple. So based on the complexity of the problem that we are solving, we can increase or decrease the number of layers. Now, coming to the problem that we are trying to solve in today's session is about image classification, which involves identifying the object and classifying that object. For example, if you look at this picture, it has a car in it. Okay, and so the objective is to identify what kind of object is present in this picture. So if you feed into a neural network, deep neural network, what will happen? It will try to extract the features out of this image. For a car, for example, a car should have two headlights, a car should have two multiple tires, it should be of this kind of a shape. So all those things will be accounted as a feature for that problem. Now once the features have been extracted by the convolution neural network, so then it will be giving us then it is fed for learning, and when the learning is done, then it is used for making a prediction. So when we are making a prediction, you can see it is the probability of the type of vehicle we can see over here. it is predicting. So for example, 95% it is saying it's a car, whereas 3% it is saying it's a truck, and 2% it is saying it's a bicycle. So based on the features that it has learned over the set of images that were fed to while training this model, then based on that we are just getting the output out of that one. Now, this is another way of visualizing this thing. So, for example, these are the different layers we can say uh, in a deep neural network. For example, the initial layer, they just try to identify the edges and gradients within the image. They don't know whether it's a human face, it's a car, or it's an elephant or chair. But if you look at the initial layer, they all look very similar because it is just trying to understand, identify the edges and gradients within that. But as we move further up to different layers, they will try to combine the features that they have extracted from the previous layer and try to come up with some more meaningful things. For example, here it has started to identify eyes, ears, the nose. Here the car parts it has started to assemble and give an output of that one. Same way for this, same way for this. And in the last layer, it will try to merge all those features and try to make a probability of that one, whether what kind of a object is there in that image. So here you can say it is identifying it as a face, here it is car, here it is elephant, and here it is chair. So this is how the upward movement will take place, and each layer will try to uh, learn something and identify something and try to club those together for the next layer. And this is the benefit of having a deep neural network. Like you can solve the complex problems by introducing multiple layers here. Now, for today's session, I'll be using a transfer learning. So, what is transfer learning? It's like there are two ways you can make a prediction. One is like by training the problem from the scratch, wherein you provide all the data, like all the images, then you train it on a very uh, heavy or a very good computing system. Then it will, once the training is done, it will give you a model which you can utilize to make a predictions. But this whole thing is very cumbersome in the sense it takes a lot of time to gather the data, plus it takes a lot of time to train those models. So already people have done those things, and for the common problems. Okay, and if you are solving a very common problem, then it's better to go with a transfer learning. So in a transfer learning, you just use the pre-trained network or the model, and you just make a prediction on that one. So that way you will save a lot of time in data collection, plus you will save a lot of time in data training also. Now coming to ML.NET, so these all things were common to any machine learning problem or a computer vision problem wherein you need to do the image classification. And this is being prominent in a lot of frameworks that are available. For example, you have TensorFlow, you have Keras, then scikit-learn, but nothing was there in with respect to the .NET ecosystem from Microsoft. So Microsoft came up with something called as the ML.NET, which is machine learning.NET framework from Microsoft, and it's pretty good for the developers who are well versed with the .NET languages and they wanted to venture into the machine learning area. So these are some features of those the ML.NET framework. Like you can build your own. That means you can create your custom models. It's a C sharp based or F sharp based code. So you are free to write like you do for in PyTorch or TensorFlow that way. And it's very much developer focused. That means you can run it locally. You can execute the things in Visual Studio Code as well as Visual Studio anywhere. You need not to have a cloud infrastructure for executing the ML.NET framework. It's extensible in the sense you can interoperate. That means the model that you have created in ML.NET, it follows a ONNX ONNX runtime format, which is a very industry standard thing. So that means you can convert it into ONNX format and it can be used in another application. Plus, if someone has developed some solved a problem in TensorFlow or PyTorch and they have converted it into ONNX format, then usually you can consume that one in using ML.NET. Just need to load that model into your system, and you can write the C# code to make the predictions, or you can train it as well. Then proven, that means it's being used for more than like 15-20 years by Microsoft internally. So some of the products they have been, which wherein it has been used, is Microsoft Bing, Office, then PowerPoint. So it's a product of Microsoft research that has come up with ML.NET, and it's open source. So currently they have open source to the community, and it's been growing very fast. So the cloud architecture for today's problem is like there is a user who's going to upload an image. So in my case, in today's demo, it will be a Postman client, which is through which I'll be uploading an image. Okay, and that upload of image will trigger a Azure function. So inside the Azure function, what we will do, we will load a ONNX model, which is stored or saved in your Azure Blob storage, and that through that we will get the model. Once the model is there, then we will feed it into the ML.NET ML.NET ecosystem. Then it will make the predictions and give it back to the Azure function, which will give us back to the client. So client would be here. It can be a user, a web application, or a desktop application, or like a Postman client. It can be anything. And these are some customer success stories from ML.NET. If you want to go, you can just read about those things. For example, Power BI, SIGParser. So there are different use cases where it is already being used within the industry. So that, let me launch the demo. Okay. Okay, so this is Azure functions that I have in my Visual Studio. And so before I proceed, I can just show you a few things. What is there? So this is the name of my function, like classify image. Okay, and it is a post type because I'm requesting a image file. So I need to have it as a post. And there are some utility functions that are written, for example, creating a temporary directory. So what happens is currently the ML.NET doesn't support any streaming of images. So it only allows you to load a image from a path. So what happens when we get the image to the Azure functions, it will be coming it as a stream. But I'll be storing that image in a temporary directory and using that temporary path of the file to load into the ML.NET framework. So this function is just for that one. Then reading model from blob. So I talked about like the model that we have, it's saved within the Azure blob. So from that, this method just reads that file and gives you a stream back out of that one. And this is for saving the model. So you are just reading the model, then you need to save it somewhere. So I'm just storing it in a temporary path. And the last but not the least is this one, class ID to level. So I'll be using a mobile net v2 framework model, and it is being trained on ImageNet dataset. So ImageNet dataset is a dataset which is trained on 1,000 classes, 1,000 classes. So this is used to convert map the IDs of the classes with their labels. So if you okay, maybe I'll show you after some time. So this is all we need to have this one. Now coming to the classes that is required to execute this one. So first one, I'll just go to the settings file. So for example, I'm using a local storage emulator. So I already started Azure storage emulator, and this is the connection string for that one. Then this is the container name within my Azure storage, and this is the file name that we have in the storage explorer. So we can see that as well. So if you look at here, this is my container name, and this is the file name that is already present in my Azure storage Azure blob. And the size of the file is 13.6 MB. So we are using MobileNet, which is a very small model with not a very good accuracy, but it's quite sufficient to have it run it in the Azure function. So the large size models we cannot use in the Azure function. The reason being, it only allows you to have a limited size of items to be executed in the Azure function. So for that, so I'll be using a consumption plan of Azure function, which doesn't allow you to have a big size of files to be loaded there. It only allows you to have till 1.5 GB. Whereas if you are going with a higher plan, then you can leverage big models for making the predictions and other things. So this is for that one. Then the size of the image that we have in MobileNet model is 224 by 224. So I just defined the height and width for those things. Then the next thing is this is about the input. So input in our case will be the image. So here we define what will be the size of the image. It's like 224 by 224. So that is being set as an attribute. Okay, and the image source is the property. So we will be providing the images for that one. And output. So for example, the output will not be a label here, it will be a score. So based on the score, we take the maximum out of that score, and we will get the label from the class ID to label method that we have defined as a helper function. So score is the nothing but the prediction made by the model. So it's an array of float. So we need to get the maximum value out of that one. And this is a quite an important part here, like defining the name column name in the output. So this is the name that is defined in the model output file. So I can show you that where we define this. So I do have this. So there is a utility called as a Natron that allows you to investigate your model, the layers within your model. Yeah. So this is the model that I've been using. And if you could see here, this is the format, Onyx format, and the input is of size 1 cross 3 cross 224 by 224. That means it has 3 channels. Then 224 by 224 is the size of the image. And this is the what I've been talking about, like the output name should match with the column name there, otherwise it will give an error. And this is what it tells, like it has 1,000 classes. So it has been trained on 1,000 classes. That means it is representing here it as 1,000. And if you want to investigate how this model has been created, you can just have a look here. Like it has a one convolution layer, then normalization here layer, then ReLU activation function. So multiple things are present here. There's some it's based on the ResNet 18 architecture. So that's all. And we want to see the packages that is required for this one. So the main package is Microsoft.ml. That is coming from ml.net. Then ml.image analytics. This is for computer vision things. In our case, it's image classification. So we are using this one. And this is for reading the Onyx files. And this is also supporting library for Onyx. This is also for, so basically these 3 4 packages are required for this problem statement. It all depends on what kind of problem statement you are using. So it will be different for object detection. It will be different for some type of a classification. So text classification, it will be different. But these are the things required for computer vision or image classification problem. So once you have these all things, then I can just go to the code part. Yeah. So this is how your basic Azure function. When you create a new Azure function, you will get a empty method like this. Now inside this, the first thing that I'm doing is I'm just reading the environment variables that are present in my JSON file, settings.json file, getting the container name, connection string, and the model name, all those things. Then the second one is as I already told you that the Azure doesn't, not the Azure, but this ML.NET doesn't support reading from a stream. So we need to save it somewhere. So I'm just creating a temporary directory for that one. Then second thing I'm doing is I'm reading the model from the blob. So blob is nothing but this file I'll be reading there. So this, once this file has been read, I'm just saving that file into the temporary path. And so this part is just for that information, getting the model file from the Azure blob and saving it into a temporary path. Now coming to the next thing is the loading model into ML.NET context. So here I am defining the input name and the output name. So we just saw the output name. This was the name that was present in that Netron model file. So it has to match with that one. The input name as well as the output, both has to be matched. So I think I can quickly show the input name also. So input name should be data in that file. Yeah, if you see here, so input name is data, this is the input and this is the output. So these two names should match over there. This is the first precondition for this. Second thing is like we are creating a ML context. So ML context is nothing but similar to what we have a DB context. So it maintains the full life cycle of the execution that will take place within the ML.NET. So this will be utilized for training, for prediction, for everything. So this will act as a central part of the ML.NET. Now creating an empty data. So this is what we are saying. Okay, this is the input type, and these are the fields that will be present in our input. So as we are leveraging the transfer learning, so we are not going to train it on a data. So we just create an empty data and pass it to the ML context. So this one, it allows you to load the data from different sources. So here we are just saying that we are saying to the ML context that, okay, this is the type of input and these are the fields or the schema that is present in the input. It has nothing to do with the actual data here. So this one gives us a data out of the ML context. Now, once we define the schema to our ML context, okay, this will be the input and this is the type of the input that it will get. Then we will define the pipeline for that one. So pipeline will include multiple transformations. So for example, the first one is resizing of images. So there is a possibility that the size of the images may vary, and whereas our mobile net architecture model just allows only 224 by 224 images. So we have defined that only, like image settings dot height and then width that we have defined here. So it will, what it will do, irrespective of the image size, it will transform into the 224 by 224 image. So this is the first transformation that the ML context will do. Then the second transformation it will do is it will try to extract the pixels out of that one. So each pixel has a value between 0 or 255. So this will allow you to extract the pixels out of the image. And the apply on X model is the third transformation, which is nothing but loading the model. So till now we were working on the image, the input image that we are going to feed. Now we want to load the model also in that pipeline. So this apply on X model is the one where we specify the saved model path. So the place where we saved, currently we saved it into a temporary path. So we provide that path and it will apply the OnX model, which is nothing but loading the model. So we are just defining the pipeline here. So it's not yet executed. That means it's kind of a lazy loading that will happen. Okay, so once we have defined the pipeline, this is a structure, these are the transformation it has to do on any input that is being fed to it. So with that, it's done. Now training part, and this is where we train the model. So it's very much similar to other frameworks, like where we fit the data or train the model. So here we are just saying, okay, empty data, this is the schema that it has to fit on, and this will give us a model. So till now nothing has been loaded. It's only the model. It knows what kind of a model it is, what kind of a input schema is there, what of transformation it has to do. That is all it is doing till now. Now once it is done, then the last part is the prediction, the main part. So wherein we are reading the image from the body of the request that has come to the Azure function, and we are ticking that one, and this is the input that we defined, wherein we define the image source is of type bitmap. So we are reading the image as a bitmap and assigning to the model input. Now our model context or the model already know what is the type of the model input is there. So this is something called as a prediction engine here, which allows you to make a prediction on the given input. So here you need to define what is the schema of your input, what is the schema of your output. So here in our case, the model output had a property called as a score, which is of a float array. So that means it will give us a float array out of this one. So once we make a prediction, so this is also, we are just defining, we are creating this one and we are making it ready, but till now no prediction has been made, and we are passing the model here. So that means which kind of a model, or what model has to use for making the prediction. Now once the prediction engine is ready, then we will make the actual prediction. So this is where the actual prediction happens. So here we are passing the actual image that we got through the Azure function. And once we get the actual prediction, then we are saying, okay, what is the score of that one, which is nothing but a float array, and taking the max value out of that one. So once we have the max value, that means will give us the max score out of that. Now we got the value, but it's a kind of a ID. It's not the label that we got. But in order to get the label, we did a created a utility function called as a class id to label, which will take the value and it will give us back the corresponding label out of that one. And this is what we are returning as like what is the score, that means what is the id and what is the label of corresponding to that one. So with that experience, I'll just run this. And this is my postman. So this is the API slash classify image, the Azure function endpoint. And here I'll select image, dog. So let's see what. First, let the function run. Okay, so this is the endpoint. So let me put a breakpoint just to debug it and show what I'm doing. So I'll hit this endpoint. Okay, so it has come here. Yeah, so I'm just reading the app settings, the container name, the connection string, the model name. I'm creating a temporary directory. So this is the temporary path for my file. Now I'll be reading the item from the blob, the model file from the blob. So the container name is serverless DNN, which we can see here as well. This is the container name. So then it will try to get the model file. The name of the model file is this. So it has successfully got that file. Then we are trying to load it into a memory stream and returning it back. Now the file has been read into a stream. And we are going to save it to the stamp path. So the file got saved to this path. And it's a temporary file, an Onyx file. Yeah. Now here we are specifying ML context. So if you see here, it has different things like for binary classification, different types are present based on the problem statement that you are trying to solve. So it has multiple of those things. But yeah. Okay. So now we are defining the schema, input schema, and trying to load it into the ML context. So schema says like one column, and this is the type for that one, 224 by 224, the image source. So it has properly read from the model input class. And here we are defining the three transformations: resizing image, extract pixels, and loading the Onyx file. Here we're just training it. So currently we don't have any data, so it will be pretty fast. Now we are reading the image from the input that we have given through the postman. So the file has been read, and yeah, it has the size of this everything. So we are creating a model, then we are creating a prediction engine. Now we are feeding it into a prediction engine, the input, and it will give us a value. So this is the value that it has given. So if you look at this, the score contains 1000, as we had, and this model is trained on 1000 classes. That's why we are seeing it as 1000 values. So we'll try to get the max score out of that one. So max score comes to 212. Now going to this. So yeah. So this is the place where we can see the ID and the name mapping. So ours was 212. It's an English setter. Okay, so before that, I'll just complete this. You see the label here, it is English setter. And we are just returning it to the Postman client. So you could see here the predicted value is ID is 212 and the label is English setter. So English setter is nothing but one type of a dog. So it's not very accurate, but yeah, it has identified it as a dog when we supplied the image of a dog only. So if you see here, I gave this images of a dog, and it has just predicted it as a dog only, but of a different breed, because the model is not that accurate, but still it worked quite well for a simple problem. So this is the place then. So this is how we can run it locally. But now if you want to have the same thing on Azure, what you need to do is you just need to go and publish it. That's all. And define these settings in your Azure account, these values, so that it will take those values instead of taking the local. So locally you need not to make any changes, but you need to make changes in your server, in your Azure function settings. So just to have that one, you can just publish it and navigate it to the Azure function profile, and it will take care of that. So I've already done that one. Maybe I'll show you that. Yeah, so the very first thing is I have that file stored in the Azure blob as well. So this is my Azure blob, the same container name I have kept just to avoid any ambiguity. So no code change, nothing is required. So this is from that. Then you have a Azure function. So you can specify the settings in the configuration. Yeah, so here you can specify those connection string and other things easily. Once that is done, then I have my function here, the same function name, classify image. So currently there is no request. I'll try to hit it from the Postman. So this is the endpoint for my Azure function hosted in Azure. And I'll use the same thing, same dog picture here as well. And let's see if it works or not. Yeah, so it is also giving. So like without any code change or anything, you can easily deploy it to your Azure function and get things up and running. So you can, the best part of this ML.NET is like you can experiment locally each and everything. It's not like you have Azure ML where you need to have the credits of Microsoft Azure, and you need to have a runtime for that one. It's only like whole development can be done locally, and once that is done, then it means You can easily deploy it to Azure Web App or Azure Functions or anywhere else. It's very easy to do those things. Now, yeah, so that's all about the demo I have, and this is the GitHub link. Maybe I'll just post it on the chat. Anyway, let it load. So this is the place where you can find each and every resource about this one. Like you have the source code, then you have the slide deck. Then if you need tutorials, so there's one tutorial that I have written that covers each and everything that I have demonstrated here. So it's an end-to-end serverless deep. So it starts with the introduction and what all things are there, plus a step-by-step things how you can develop this application and host it on Azure as well. So each and everything has been written here, just in case if you want to refer this thing. And it also has few things, the few mentions about the issues that I faced while building this application. So I have highlighted those as well. For example, I'm highlighting this input and output. Then I have highlighted there is one issue with the X64. So I have provided a workaround of how to overcome that problems also. Then this is it for the local one. Now to the serverless using cloud, Azure cloud. So there also I faced a couple of issues and I tried to overcome that. This is one of the error that I faced. So I had to overcome that one, provided a solution for that as well, like changing the platform to 64-bit. That will allow you to overcome that. So everything is present in this as well. Also, it's there on this. Sorry. So that's all I have. So resources are present, and there are some references, some good references for ML.NET plus uh, Azure functions. And I think that's all. Sorry. No, I'm saying that there are some resources or references are present.
Cool. So awesome. Thank you so much for that, Praveen. That was very interesting. It doesn't look like there's any questions in the chat, as far as I can tell. But I did have a question, if you don't mind. I was just
Yeah.
wondering what from based on your experience, when you're building a solution like this, what are some of the biggest challenges you've faced, and how have you gone about solving those?
So there are multiple things involved. I think that's a great question, and every person has that kind of a question. So it's more of like first thing is you need to understand your problem. Okay, what kind of problem you are solving? For example, here I was solving a problem of image classification. So it's not under your machine learning, AI, ML, and computer vision, you have multiple things. So here we are just solving one type of a problem, which is image classification, whereas other types could be object detection and other things. So first of all, identify the problem, then identify the what is the output that you expect out of that one. So if it is a image classification, I would say, okay, then you need to identify whether you need to train it the things from the scratch, or if you have something existing present. So in my case, I leverage the transfer learning. That means I leverage the existing model, which is already trained on these kind of objects like cat, dog, and shape, and all those things, which is a generic problem. But if you have a very specific, then you need to go much deeper and see how you can train the model. You need to collect the data. So that's a big challenge, collecting the data, and training also. Training requires a lot of compute. The third thing that I faced was the size of the model. So for this, the demo purpose, it's okay. You can have a small model. Like in this case, it was a 14 MB only, which can be easily loaded within your Azure function. Whereas if you want to, if you're solving a big problem or complex problem, which is having a very heavy model, that in that case you need to have a compute infrastructure available. So you can't put it on your Azure functions. You need to use VMs and other things for that. I think basically these are the three main areas I would say we need to take care of while building such kind of a solution.
I see. Awesome. Thanks for that. Just quickly, I think someone's looking for the GitHub link. If you could post that into the StreamYard chat, that would be awesome.
Yeah, just
Yeah, no worries.
I just shared. I think.
I can't see it in the chat either. But if you want,
Let me quickly share it.
yeah, you could post it into. If you're part of the WhatsApp group, I'm not sure if you are. You can post it there, and I can post it
I'll
into
just
the
quickly
chat.
share. Just a minute. I'm just sharing it.
Yep, no worries. While you're doing that, I did have another question.
Yep, sure.
One of the biggest points when you're talking about machine learning to the business and when you're trying to build your solution is the accuracy and the metrics surrounding that. What are some techniques do you think? Well, what do you think the best techniques would be to try and improve your accuracy if it's not at a good enough point for production?
So there are different ways to achieve that one. So first, the data cleaning is important. Just a minute. So data cleaning is one. Then you have different type of architecture you can use. Okay, maybe like RESTnet, eating, then with the architecture which is having multiple layers. Okay, large number of layers. So architecture, data cleaning, and then tweaking the last layers in the model. So which is, instead of classifying for like 1,000 classes, maybe you can classify for your number of classes that you have a problem statement for. For example, if you're just trying for 10 classes, so better to use that one. So I would say these are the some ways.
Awesome. Thank you. That makes sense to me. I still can't see that link. I'm just trying to see. Could you post it in the StreamYard chat? That might be better.
Yeah.
I'm not sure if.
It's not working. Are you able to get it on StreamYard now?
We still. Oh yes, I've got it now. Awesome. Okay, I can post that now. Awesome. Thank you.
Yeah.
Cool. Just posting that now. All right, fantastic. Thank you so much, Praveen. That was very informative, very interesting, and the demo was very helpful as well. Sort of gives us a look into actually how it works instead of just a slide deck. So that's really cool. This is our last session for today. So there are more sessions.
Thank you very much. Yeah, thank you very much, and I think it's a great effort by the team behind the scenes. Really appreciate that.
Thank you. Yeah, no worries. Awesome.
Yeah.
But yeah, cool. Just to let the audience know, there are 2 more sessions tomorrow, and there are more sessions in Spanish later down the road. So I will post quickly the site into the chat, so please look there for more information. Just posting that now. But yeah, thank you everyone for joining. I hope you've found this valuable, and we'll see you next time. Thanks.
Thank
See
you.
you.
Bye.
Bye.
Bye.